In this video, we're going to be solving systems by substitution and answering the question, how can you solve a system of two linear equations by using substitution? First, let's look at an example. In the example problem, we can see that both equations have a y equal to, and that's a perfect opportunity for doing substitution. I look at the top equation as blue and write 2x plus 6 is equal to, and now I make my bottom equation green. So 2x plus 6 is equal to negative 3x plus 16. This is going to give me my first step in solving systems by substitution, which I'm going to substitute one equation into the other. Now all I'm going to do is, back at solving equations earlier in the videos, I'm simply going to solve for x. I've moved the small x. I'm going to isolate my x. So I'm using the addition property, subtraction property, and division property of equality. This gives us now onto step 3, substitute x into an original equation and solve for y. I'm going to use the top equation, which I marked as blue, because it seems that it would be easier to multiply by that one. I get y is equal to 2 times something plus 6. And that something is the x that we found earlier. I substitute that value in. And now all that's left is to combine like terms, solving for y. Once we have the y identified, all we need to do is place these two variables into an ordered pair in alphabetical order, x then y. So 2, 10 is our answer. And ordered pairs, x, y, is our step 4. Here we see the 4 steps to solving systems with substitution. A good keynote about step 1 is that to best use this system, we might set both equations into slope-intercept form, or y is equal to mx plus b. Let's look at another example. We have x minus 2y is equal to 6, and x is equal to 3y plus 16. I see the x equals 3y plus 16, so I'm going to substitute that x into the top equation, giving me a new equation of 3y plus 16 minus 2y is equal to 6, where all I've done is substituted the x value from the second equation into the first equation. All I have to do here is solve for y instead of our step 2 that says x. I combine like terms, subtract 16 from both sides, which gives me negative 10 on the right. This video is wrong in that it has a positive 10. Knowing that y is negative 10, I'm going to substitute that value into the bottom equation from the originals. So 3 times negative 10 plus 16. Again, this is written wrong here. So x is equal to negative 30 plus 16, or x is equal to negative 14, not the 46 that's been written here. My ordered pair is negative 14, 10. Unfortunately, without my owning a printer, I couldn't reprint this page to reshoot the video, so I had to leave that old video where it was. Finally, we have this third example, and it is not set up in a convenient form for me to do substitution. So I'm going to say simply don't use substitution in this case, unless you want to make both of those equations into slope-intercept form. E.T. Bell once said that obvious is the most dangerous word in mathematics.